So this next lesson is on solving systems of equations by graphing. Now, what a system of equations is, and I'm not going to spend a ton of time talking about this because it really is pretty simple. It's just when you, and for our purposes, when you have two equations and they're on the same graph, and the system of equations, what they want us to find is where do these equations meet, and where they meet is where the solution is. So in other words, you're looking for a point or a set of points that works not in only one of the equations but in both of the equations. So we're going to talk about solving these systems of equations in this first lesson here by using graphing methods. All right, I thought it would be a good idea to show you one quick other way to graph an equation if for some reason your mind just blanks and you completely forget how to use slope-intercept form. Now, having said that, I want you to know that slope-intercept form is clear in a way the fastest way to graph a line. It's faster than anything. If it's in that form, that's really what you should do, only because it's set up for that. That's why it's written like that. It's meant to be done like that. But supposing, it's been a long weekend and you completely forgot. So all you need to graph a line of any kind is 2 points. All right, so we got X and we got Y. So usually what I do is I say, well, pick any two values for X. And you want to be smart about the values you pick, because you don't want to pick something that's like off the graph either in the X or the Y direction. So you look at what you have and you say, okay, well, I'm taking X and multiplying it by 2 and I'm adding 3 to it. All right, so anything in the realm of within 5 or 6 X of 0 of the origin will probably work. So what I usually try to do is I try to use 0 first. And the reason I use 0 is because it takes this whole term and it gets rid of it. And then you're just left with this negative 3. So because negative 2 times 0, and then you're left with negative 3. You got 1 point really quick. And then for this one, I would say, I'm looking at my graph, and I would say because it is a pretty large graph, I'm going to use 3 because it'll give me a little separation. So then you plug it in, you take 3 and you plug it into this. So that's going to give you negative 2 times 3 and then minus 3. So you're writing this equation out, but you're substituting in for your X value. So negative 2 times 3 gives me negative 6 minus 3. So if you have negative 6 and negative 3, that gives you negative 9. So I now have 2 points. I have the point 0, negative 3, which is right here. And I apologize that this probably will not look very pretty because I'm using a very messed up stylus. So, and then we go down 6 and then to 9 again, negative 9, which puts me here, and then go over to 3 for my X. And now I've got 2 points and I can graph a line. And that's all you need. You need two points. I usually suggest making sure that there's a little separation between them if possible, because then that gives you a better sense of the line. The other thing is when you are doing this on paper, it's really important for graphing systems of equations that you're very exact about it. So obviously I'm doing this on a tablet and can't put a ruler on there and do all these things, but you're going to want to use rulers and you're going to want to make it look as good as possible. All right, so let's look at one other case. So same thing, you can do, now this one, the fastest way to graph this one would be by doing your intercepts, right? But what I'm going to do is I'm going to show you kind of another way of using the intercepts, but approaching it from a table. All right, so I'm going to pick 0 again for X because that's what I always think is the smartest way to do it. So if I do that, that gives me 4 times 0, which is 0. So it gets rid of this term, and you're left with this equation, negative 2y equals 12. Well, you just solve for y. Solve for y by dividing by negative 2, and you get y equals negative 6. So we've got 1 point now. And then the next thing to do that would probably make the most sense is let's let's see, well, what happens if I put 0 in for y? And normally we plug a value in for x and get y, but when they're set up like this, we can reverse it. So let's put 0 in for y. And when I do that, that gets rid of this term, because 2 times 0 is 0, and the negative sign goes with it, and you're left with 4x equals 12. Well, if you have 4x equals 12, you divide each side by 4. These are to be ignored here. That cancels out, and you get x equals 3. Right? I have 2 points now. I have the point 0, negative 6, which is down here, about right there. And I have the point 3, 0. I have 2 points. In case you didn't recognize what we were doing, we were actually graphing by using x and y intercepts on this, but I wanted to show it to you in the form of a table. And then we just draw a line that goes through it. Try to occupy as much of the graph as you can with your line, and you're good to go. So when you are graphing these, if you forget how to do x and y intercepts, or you forget how to do slope-intercept form, there is this alternate method of just picking a couple values for x, plugging them in, see what you get, and just get yourself 2 points. And then you can get started.